Hello everyone, welcome back to my channel. Here we talk about the determination of the resultant vectors, and this is in connection with the last video on non-perpendicular vectors. Now the resultant is represented by a third side of the triangle formed by drawing a line representing the vector of P followed by a line representing the vector of Q. As you can see here in this diagram, if we call this I, this 2I. So we represent P here as it is in this diagram, and Q is just shifted across to the end of P and it's drawn in the same direction, Q going downwards that way. And the resultant forms the triangle. Note that the resultant is represented in magnitude and direction, but not necessarily position. So though you see Q here, it's not necessarily in that position as you can see in the vector triangle. Same here in the second part here, we have P acting downwards, Q this way, and the resultant forms the third part of the triangle. Now, using the cosine rule, and if you are not too familiar with that, if you look at my previous videos, I've covered the cosine and also the sine rule. Now we have that r squared resultant is equal to p squared q squared minus 2p q cosine of 180 minus theta. Now, another thing is that cosine 180 minus theta, I've covered this in my trigonometry problems that and concepts that I've gone through in previous videos, is equivalent to cosine theta. So now we can write r squared is equal to p squared and q squared minus 2pq cosine theta. I think most people are familiar with this version of the formula. Now the direction of the resultant, so direction of r, it can be determined by using the sine rule. So we have that sine alpha over p equal to sine 180 minus theta over r, which we can write as sine alpha equal to p sine theta divided by r. And so now we have both the resultant that we can calculate from using the cosine rule and the direction of this resultant using the sine rule. Now these two formulas are valid for calculating the values of the resultant r and alpha, whether theta is acute or obtuse. So it will apply in both cases. Thanks for watching this video. Don't forget to like and please subscribe to my video. Thanks. Bye for now.